For decades, movies have shown black holes as giant black circles floating in space. But that's not what you would actually see. If you somehow survived the journey and slowly approached a real black hole, the view would become stranger than anything Hollywood has ever imagined. Space itself would appear to bend. Stars would twist into impossible shapes. Light would travel along curved paths, making objects behind the black hole appear above it, below it, and even wrapped around it in glowing rings. The closer you moved, the less your eyes could trust what they were seeing. You wouldn't be looking at an object. You would be looking at reality itself breaking down. Most people think a black hole is simply a region of darkness. In reality, it may become one of the brightest places you could ever witness. Its surrounding disk of superheated gas can outshine entire galaxies, reaching temperatures of millions of degrees. Matter races around the black hole at speeds approaching the speed of light, releasing unimaginable amounts of energy before disappearing forever. Yet at the very center, there is nothing to see. No surface. No solid object. Only a perfectly dark shadow surrounded by light that has been bent into impossible circles by gravity itself. This isn't science fiction. It is exactly what Einstein's theory of general relativity predicts. And remarkably, modern telescopes have already captured the first real images proving that this bizarre prediction was correct. Now imagine you're not observing a black hole from millions of kilometers away. You're flying directly toward one. At first, nothing seems unusual. The black hole doesn't resemble a giant vacuum cleaner pulling everything toward it. In fact, if our Sun were magically replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does today. Gravity depends on mass, not on whether that mass is a star or a black hole. But as your spacecraft moves closer, reality begins to change. The first thing you'll notice isn't darkness. It's distortion. The stars behind the black hole start bending into strange arcs, as though the universe itself has become liquid. Light that should travel in straight lines is forced to curve around the black hole by its immense gravity. Astronomers call this gravitational lensing, and it creates one of the most extraordinary sights in the cosmos. Soon, entire constellations appear duplicated. Stars that should be hidden behind the black hole suddenly become visible, wrapped into glowing rings around an invisible center. The universe begins folding over itself like a cosmic mirror. Then another surprise appears. The black hole itself is still invisible. What you're actually seeing is its shadow, a dark region created because photons crossing a critical boundary can no longer escape. Around that shadow blazes an incredibly bright ring of light from the surrounding accretion disk, where gas spirals inward at relativistic speeds. Temperatures soar into the millions of degrees, making this region brighter than billions of stars combined. As you continue your approach, the contrast becomes almost impossible to comprehend. At the center lies absolute darkness. Around it burns one of the brightest structures in the known universe. And all of it exists because gravity has become so powerful that it no longer bends only matter. It bends light itself. The closer you get, the stranger the universe becomes. By now, your eyes can no longer trust what they see. Looking straight ahead, the black hole appears surrounded by a brilliant ring of distorted light. But when you glance to the side, something impossible happens. You can still see the black hole. Its gravity is so extreme that light from every direction is being bent toward your eyes. Parts of the universe that should be completely hidden suddenly become visible. Galaxies behind you seem to appear beside you. Stars stretch into glowing arcs that wrap around the darkness like molten glass. It feels as if space itself has lost its geometry. The closer you move, the stronger this illusion becomes. Then, something even more unsettling begins to happen. Time itself starts changing. According to Einstein's theory of general relativity, gravity doesn't simply pull on objects, it also slows the passage of time. Near a black hole, this effect becomes enormous. To you, everything inside your spacecraft feels perfectly normal. Your heartbeat remains steady. Your watch ticks exactly as it always has. But to someone watching from a safe distance, a completely different story unfolds. they would see your spacecraft slowing down. Every movement would become more gradual. Every second would seem longer than the last. As you approached the event horizon, your motion would appear to freeze almost completely. Your image would become dimmer, redder, and fainter until it slowly vanished from sight. From their perspective, you would never actually cross the event horizon. You would simply fade into darkness forever. But from your own point of view, you would continue moving forward without noticing anything special at the exact boundary. There would be no wall, no shockwave, no invisible barrier waiting to stop you. Just one silent moment, when there is no longer any path leading back to the universe you once knew. And beyond that invisible line, EV. There is a common misconception about black holes. Most people imagine that the event horizon is some kind of solid wall, a point where everything suddenly changes. But reality is far stranger. If the black hole were large enough, you might not even realize you had crossed it. There would be no flash of light, no violent impact, no invisible force pushing you back. Your spacecraft would continue drifting forward exactly as before. Your instruments would appear normal. Your heartbeat would remain steady. For a brief moment, everything would seem unchanged. Yet something fundamental has happened. Without seeing it, without feeling it, you have crossed a boundary unlike any other in the universe. The event horizon is not a physical object. It is a one-way border written into the very fabric of space-time. Outside this boundary, light can still escape. Inside it, nothing can. Not light. Not information. Not even time can carry a message back to the outside universe. From this point forward, every possible path through space-time leads deeper toward the center. Trying to escape would no longer be like swimming against a current. It would be like trying to travel into yesterday. The geometry of the universe itself now points in only one direction. Downward. Inward. Forever. And then, the black hole reveals its final illusion. Looking behind you, you would still see the universe. The stars. The galaxies. The place you once called home. But something feels terribly wrong. The light arriving from outside becomes increasingly distorted. The universe appears compressed into a smaller and brighter region of the sky. Colors shift dramatically. Time outside seems to accelerate. Events that once took years may now unfold before your eyes in minutes. Entire civilizations could rise and fall. Stars could be born and die. Galaxies could slowly change their shape. While you continue falling for what feels like only a short time, you are no longer simply traveling through space. You are traveling through a region where space and time themselves have exchanged roles. And somewhere ahead, hidden beyond every beam of escaping light, lies one of the greatest mysteries in modern physics. What happens next? No one knows. According to Einstein's equations, every object that crosses the event horizon is destined to continue falling toward the singularity, a point where gravity becomes infinitely strong and our current understanding of physics completely breaks down. But many physicists believe the true answer may be even stranger. At the heart of a black hole, general relativity and quantum mechanics, the two greatest theories ever created, begin to contradict each other. One predicts an unavoidable singularity. The other suggests that nature may never allow infinities to exist at all. This is where science reaches its limit. Some theories propose that the singularity doesn't actually exist. Others suggest that black holes could contain hidden regions of space-time, quantum structures, or entirely new forms of physics that we have yet to discover. There are even hypotheses that information is never truly destroyed, but somehow encoded on the event horizon itself, waiting for a deeper theory of the universe to explain how. Today, no experiment can tell us which idea is correct. Every black hole remains one of the greatest unsolved mysteries in modern science. And despite decades of research, we still don't know what truly lies beyond the point of no return. Ironically, The darkest objects in the universe have become some of the brightest sources of scientific discovery. They have allowed us to test Einstein's theories with extraordinary precision. They have revealed how gravity bends light, slows time, and shapes entire galaxies. In 2019, humanity captured the first real image of a black hole's shadow. For the first time in history, something that once existed only in mathematics became visible. It was not simply a photograph. It was proof that the universe is even stranger than our imagination. So, what does a black hole really look like up close? Not like a giant hole in space. Not like a cosmic vacuum cleaner. But like a place where light curves, time slows, reality distorts, and the laws of physics are pushed to their absolute limits. A place where the universe stops giving simple answers and starts asking questions we are only beginning to understand. Perhaps the greatest mystery is not what a black hole looks like. Perhaps the greatest mystery is what it still refuses to reveal. Because somewhere beyond that perfect circle of darkness, the next revolution in physics may already be waiting.